Welcome to Rges Algebra 1, Lesson 16A. We are continuing our conversation with how to graph lines. And let's say we have an equation like 3x plus 2y equals 12. We know this is linear because we have two different variables, in this case an x and a y, both to the first power, and that indicates a line. Now, to graph a line, all you really need is 2 points. We often have you write a table and maybe have 3 or more points. But that's certainly not the easiest way to graph a line, so we're going to be learning at different ways. Now, it only takes 2 points to define a line. We usually use the third point as just a check to make sure we did nothing wrong. Now, if we're going to take this equation up here and we're going to define 2 points, two of the easiest points to find would be where it crosses the x-axis, or the x, we call that the x-intercept, where it intercepts the x-axis, and the y-intercept, where it intercepts the y-axis. Now recall a graph. Where it crosses the x or the y-axis, in this case, where a line crosses the y-axis, what would the value of the x be? We don't know what the value of the y is, though it's right up there, right? It's that many high, however many that is. But what is the value of the x? We know. The value of the x when it crosses the y-axis is 0, because we're not going to the right and we're not going to the left on the horizontal axis. So, and by the same token, if we're crossing the y or the x-axis here, this is the x, this is the y. If we're crossing the x-axis, we don't know what the x value is. It's a certain amount over in this direction to the right, this many, but we have to figure out how many. But what is the value of the y? The value of the y, it's not going up on the y-axis, it's not going down on the y-axis, so the y value is 0. So hopefully you could think that through every time you need it. Okay. Now, so if I go back to my equation here, 3x plus 2y equals 12, and I plug in y, for my y, I plug in 0, I will find the x-intercept. I'd say 3x plus 2 times 0 equals 12. 3x, 2 times anything, or 0 times anything is 0. So 3x equals 12, divide by 3, and x equals 4. So it crosses, sorry, let me go back, write that in. It crosses the x-axis at 4. Now, to find the y-intercept, I would put a 0 in for my x value, and I would get 2y equals 12, dividing, I would get y equals 6. So if I have a graph, and if I have an equation that's linear and I want to graph it, I simply plug in a 0 for my y, and on the x-axis, I'll solve for the x-intercept. 1, 2, 3, 4, it crosses the x-axis. Or I plug in a 0 for my x, and I solve for the y-intercept, and I plot 0, 1, 2, 3, 4, 5, 6, and I plot that point there, and then I simply draw the line, and that's my L for line. Sorry, usually it's line 1, line 2. Having a hard time writing today, and that's all there is to it. So we've talked about the x-axis, or the x-intercept, and the y-intercept. Let me give you a second example. This is straight out of the book. I recognize this as a linear equation. To find the intercepts, I plug in a 0 for the x and dividing by negative 3, I get y equals 10. So my point would be, what was my x? 0, and my y would be negative 10. And then I plug in a 0 for the y. Divide by 5. My x value is negative 6. My y value was what I plugged in for the y, my 0. And now I have 2 points. Simply a question now of graphing them. Go to 0 and go negative 10 on the y-axis. Down to something like this. Don't need that extra line in there. It's just showing that I was going down, and I'm just going to label that, doing it kind of sloppy here. This would be 0, negative 10. And then on the, the second point, go to negative 6 on the x-axis and 0 on the y-axis, and that's where it crosses the x-axis. And whoops, you know what? It's positive 10. I'm sorry. Positive 10. So I would really be up here somewhere. There we go. And my line would go down like that. Okay, so apologize. I'm trying to write on a couch here. It's a little bit challenging. So a little sloppier than normal. Now let's go to your oral practice on 287. And they're asking you to quickly identify the y-intercept. For instance, the first one, it says 3x minus 2y equals 18. If we want to identify the y-intercept quickly, we're not caring about the x, we're just thinking this, and divide by negative 2, and the y-intercept is negative 9. Again, if we had 4x plus 3y equals 24, if I asked you to identify the y-intercept, you were not thinking about the x value, only this, divide by 3, and y equals 8. Very quickly, you just see it at a glance. If we could do it the other way, 2x plus 5y equals negative 100. If I ask for the x-intercept, I'm thinking where it crosses the x-axis, divide by 2, and x equals negative 50. Just like that. Okay? So you can do yourself some practice with those. Now, you will want to go get your book and turn to page 288. And I'll meet you back in a minute. Now, referring to your book, it's graphing lines, and it says give the x and y intercept. So for M, the x-intercept is where it crosses the x-axis. So you would just read that point off, and it would be negative 7. The x-intercept is negative 7, and the y-intercept is where it crosses the y-axis, and that'd be 2, 4 at 5. For N, where it crosses the x-axis, you're just simply reading off the graph. It's crossing it at 3, and where it's crossing the y-axis is at 2. So make sure you are comfortable with those problems. So putting all this knowledge together very quickly, we're going to calculate the x and y intercepts and plot. Okay. Again, to calculate the x, I'm only interested in the x, divide by 4, and I'm going to get the x-intercept equals 6. The y-intercept, I'm only interested in the y above, so divide by 3 equals 8. Graph it, go over in the x-axis to 6, and on the y-axis higher. And of course I'm just demonstrating, I'm not really doing this in graph paper or anything, but I think you get the idea. To do it again, the x-intercept, divide by 3, and I get 12. The y-intercept, divide by 4, and I get 9. To graph it, on the x-axis, I go to 12. On the y-axis, I go to 9, and I draw my line. Very simple, very fast. Okay, so you should have no problem with those. Now the next idea is 7.5, and we're talking about slope. We define slope as well, they talk about the rise over the run, the rise being the vertical change, and the run being the horizontal change. Horizontal, I use a triangle for change, vertical change. Okay. We could also define this as the change in the y over the change in the x. Okay. Now, what do I mean by the change in the y over the change in the x? Here I have 2 points, and I identify them with their ordered pairs down below the axis. And I'm asking, what is the slope of that line that's represented by the segment AB? Well, A is 2, 1 as its values, and if we wanted to know the change in the y, we could go, well, the change in the x would be that, and the change in the y would be that. Okay, so I would take the difference in the y values. What's the difference when you're going from 1 to 3? You've moved over 2 points, so my slope, which is often represented by m, because recall the general equation. I'm not sure I taught that to you yet. I can't remember. You or the other class, but this is the slope in the general equation, and this is the y-intercept. So my slope is the change in the y. The change between 1 and 3 is 2, and the change in the x's, the change between 2 and 7, is 5. So there's my slope. Now, if instead my a was, let's say, -3, -9, and my b was 2, 4, again, I'm just saying that the slope, which is also represented as m, is the change in the y, always the vertical first. What is the difference? What on a number line? How many spaces are there between -9 and 4? That'd be 13. How many spaces are there between -3 and 2? That would be 5. So very simple to look at it that way. So now he goes on and actually introduces what I could not remember if I had taught you yet, and that is right now. This is called the slope-intercept form of a line, or form of a linear equation, right there. Okay, so you set it equal to y, and whatever the value or the constant is before the x, that is my slope. And whatever the constant, I should say whatever the numerical coefficient is before the x, that's my slope. Whatever the constant is, that's where it crosses the y-axis. So let's put that information to use here. Let's go ahead and graph these then. I'm looking first at the y-intercept. It crosses the y-axis at 4. And then my slope is 3. Now 3, recall, put this in fractional form, 3 over 1 means I go up 3, because that's my vertical change, from the first point, from the y-intercept. Go up 3, and to the right, my horizontal change 1. So my first line is there. For the second one, you start at where it crosses the y-axis. It starts at 1, that's my first point. Now my slope is 2/3. The numerator represents the y change, so I'm going to go up 2, and the denominator represents over 3. up 2 over 3, and there's my second point, and there's my line 2. Finally, for the line 3, I go down 4 on the the y-axis, because this is where it crosses the y-axis, -4. And then my change, I'm always considering a fraction. I go down 3 and write 1. My change in vertical is down, -3, and my change in horizontal is to the right 1, and my third line is like that. So make sure you understand how to graph 1, 2, and 3 using the slope-intercept method. Now, notice the first two are sloping upward from left to right, and they are both positive slopes. So whenever we have a positive slope, we're going to slope upward from left to right. The last one, line 3, is sloping downward from left to right, and it has a negative slope. So a negative slope is has a line going down from left to right. Only a couple more ideas and we're done. So what would happen if we had a horizontal line? Well, my change in x, my x is changing, but my y is not. So this would represent 0 over something, or my slope is 0. On a horizontal line, the slope is 0. Now, what if you were looking at a vertical line? A vertical line like this, my y value is changing. It's changing. Could be different values, but my x value never changes. Well, this is a problem for us. We can have vertical lines, don't misunderstand me, but what is the slope? We're not allowed to divide by 0. Remember? That's undefined. And so the slope is undefined when you have a vertical line. I should say the slope is undefined. And on a horizontal line, the slope is 0. So this is the last major idea. Now don't forget to use the slope-intercept equation to read off the slope is here, the y-intercept is here, but notice you must have y equals. So if I instead have 2y equals 7x plus 14, I have to convert this to y equals. So you have to manipulate. I would have 7 halves. Whoops, that's not a half. 7 halves x plus 14 divided by 2, or 7. Now my slope there would be 7 halves, and my y-intercept would be 7.